In this video, let me show you how to do the part where you calculate the time constant 5 times, okay? What we need to do is pick 5 ordered pairs, really 6, you know, because this first one, and I'm just going to find them out here. So I did 300 points, so I'm going to do every 60. So let's find 60. There it is. Copy. So this is another ordered pair. So 0, this is, by the way, my V0. Okay, so when we do the calculation, that's what we're going to use for the V0. And then this is just time 1, voltage 1. So this is time and voltage. I'll just say voltage and volts just to be, you know, contrary. And now let's look for 120 seconds. There it is. I'm just copying these. Let's see what I'm going to do here. Okay. Let's find 180. There it is. Copy. Let's find 240. Whoa, so fast. There it is. It doesn't have to be totally evenly spaced. You could just really, you sort of want to space them out through the data. It's my own OCD that I'm. So we've got 1, 2, 3, 4. And we'll have 5 ordered pairs besides the original one, right? Where is it? There it is. Copy that. You could just write these down. You don't have to do what I'm doing. I'm just in blue pen land here. Okay. And then what I want to do is I'm going to grab these guys and I'll show you how to calculate the. So let's go into here and paste that in where we go. And let's make a pen, shall we? Blue pen land. All right. There we go. So our formula for this is that the voltage at any time is the original voltage times e to the minus time divided by RC. And RC is the time constant. Okay. So this is my V0. So whenever I do this, I'm going to use 4.766, I don't know, I'll use 4.7665. I don't want to type in all those numbers. I really don't think we need that many sig figs, right? So that's what I'm going to type in. This is my V0 right here. And then I'm going to use, this is my T, and this is my V, okay? So I want to solve for this RC. And I like to do it algebraically first. So let's solve for RC here. First step, let's see, I think V divided by V0. And let's take the natural log of that. And then that's going to be negative T over RC, right? Okay. Our next step would just be, I guess, RC equals, I could just leave it as negative T divided by ln of V over V0. Now, if you want to get rid of the minus sign, just take the reciprocal of whatever's there, right? Okay. So let's figure out the first one here, right? So RC1, I'll call this RC1. Okay, is going to be the opposite of the time, so the opposite of 60, divided by the natural log of the original, the current voltage, which is 2.5887, divided by this voltage, which is 4.7665. Okay. So for V0, I'm using because I think that's enough sig figs. I just rounded it to here. Okay. And I'll round all of these to there because I just don't feel like typing in all of those things. So 2.58 2.5887, right? We'll go 4 digits past the decimal point. Okay, so if I do this, I should get something that's really close to 100, but let's just see. The opposite of 60 divided by the natural log of 2.5887 divided by 4.7665, right parenthesis, and I get 98.28. All right, and now let's figure out the next one. This will be this guy here. So RC2 is going to be the opposite of, here's my time is 120, right? So the opposite of 120 divided by the natural log of, well, let's see, it's 1, let's round it to this place. So 1.4268. Divided by, and then this is always 4.7665. So literally I can take in my calculator and just grab the value that I just did and just change those values. So 1.4268, and then I need to change this to 120, and I get 99.5. Okay, you could do this in the spreadsheet too if you wanted to. And then let's do RC3 is equal to, let's see, the opposite of 180 divided by the natural log of 0.79140. Notice I'm carrying 5 digits. I'm not just rounding to the 4th decimal place. And then this is 4.7665. So literally I'm just going up arrow on my calculator and changing this. 0.7914. All right. And then this is going to be 180. I get 100.2. Right, and these, by the way, have the units of seconds. All right, let's see. And then RC4. All right, is going to be negative 240 divided by the natural log of 0.44205. Over 4.7665. All right, let's do that. 4. And let's change that to 240. I'm just literally going up arrow and grabbing it. So that's 100.8. All right. And then let's see. Eraser, let's do the eraser. I need some space here. All right, let's go back to pen. All right, and then RC5 is this guy here, right? And that's going to be the opposite of 300 over the natural log of 0.24811, I think, right? That's what we do. And then, because we rounded this guy, 1, 2, 3, 4, 5, yeah. 4.7665. So again, I just hit up arrow on my calculator and enter. Edit the values I typed in. 0.24811. $101.5. Okay, seconds. All right. So now the question is our children learning? No, sorry. Our question is that we just evaluated the value for RC, and RC should be a constant. RC should be a constant. And you would expect there to be some sort of random error on this, right? But this doesn't look random to me. It increases monotonically, doesn't it? It always went up. Well, the odds of it increasing 4 times in a row are 2 to the 1 and 2 to the 4th, right? So it isn't 2 to the 4th 16, right? So there's a 1 in 16 chance that this is random error here. Okay, so something's going on here, and then the answer is that the capacitor is not an ideal capacitor. The capacitor probably leaks charge a little bit. Okay, there's something, I don't know, something wrong with it. It's probably old, or I don't even know. Okay, but our model certainly is not actually following what it should do, right? So that's what you write about. Just talk about it. Say if they just bubble around, if it goes up and then down and up and down. But at least when I did this, it monotonically increased with time. So there definitely is a pattern, and that's what you want to talk about. What's the pattern in these? As time goes on, does it monotonically increase? Does it monotonically decrease? Monotonically means it doesn't reverse itself, right? It just always increases, okay? So anyway, that's what you talk about, and that's how you calculate it. I think I'll just sort of stop talking.